Okay, so which one do you want to do first? Factoring? So if we were using the factoring strategy, put your brackets, make it equal to 0. The only way you can get 5x squared would be 5x and x. Is there any way that you can multiply to get 6 so that the outside and the inside makes 13? 3 and 2. So we would go 3 here to make plus 15, minus 2 there makes 13. Excellent. And so then your solution, split it here. What would make this one 0 is if x is negative 3. What would make this one 0 is if x is 2/5. The factoring strategy is often the fastest, but the problem is not everything can be factored. Strategy number 1. So in this case, this might be the best one. I would say personally, strategy number 2 in this case is probably the worst one. Because if you're going to complete the square, and when we completed the square with equations, do you remember that we moved the constant value over to the other side? So completing the square with functions, we had the spaces on the same side. When we completed the square here, we had the spaces on opposite sides. But I can't really draw the spaces yet. I'm going to move them down because the first step is factoring out the 5. And this is why I'm thinking you're not going to like the completing the square in this one. So what number do we have in the middle? 13 over 5. Does that seem nice? No. But doesn't mean that it can't be done. Fractions should just slow us down, but shouldn't cause us to stop, because we should be pretty good at fractions by now. And the good thing is sometimes questions like this allow us to practice them. Yay. So what would I put in here if this is going to be squared? X plus 13 over 10. And then what would go in the purple space? 169 over 100. Whew. And so what have we actually done? We've actually added 169 over 20 to that side. So we would add 169 over 20 to that side. At this point, you're really liking the fractions, right? Okay. And so if I add these together, I need a common denominator. 6 is the same as 120 over 20 plus 169 over 20 would be 289 over 20. I can see already things are starting to look nicer. With the completing the square method, we wanted to get what was squared by itself. So I will now divide both sides by 5. Dividing by 5 is the same as multiplying by 1/5. So I can get the x plus 13 over 10 squared by itself. And if I divide both sides by 5 or multiply both sides by 1/5, I get 289 over 100. Those are both pretty numbers. Why? They're both perfect squares. But you probably don't recognize the 289 one very good. What times what is 289? 17 times 17. So now when you square root both sides, plus or minus, square root of 289 is 17, square root of 100 is 10. So we get plus or minus 17 over 10 minus 13 over 10 that would give us two answers. If we use the plus 17, 17 minus 13 gives me 4 over 10. If I use the minus 17, negative 17 minus 13 is negative 30 over 10, which is negative 3. 4 over 10 reduces to 2 over 5. Did we get the same answers as factoring? View, zoom, entire page. Okay? So comparing the blue work to the green work, yeah, I like factoring better than completing the square in this example. But that's not always the case. There are some times where I think that completing the square is the fastest method. So it just depends on the question. Just because one of them is long, like this one, the completing the square was long, doesn't mean you like completely forget about that as a technique. And finally, our final thing for review, the quadratic equation. We'll do that one in black. On your formula sheet, you have a quadratic formula. And so with the quadratic formula, you just have to plug in values. B is 13, so negative 13 plus or minus b squared would be 169 minus 4 times a, which is 5, times c, which is negative 6, all over 2 times a, which will be 10. Negative 13 plus or minus the square root of 289 over 10. Negative 13 plus or minus 17 over 10. And I'm just going to put arrows here because if you did once with adding, you would get 4/10, just like before with completing the square. And if you subtracted, you would get negative 3 as well. So the quadratic formula in this case appears to be nicer than completing the square, although we get almost identical numbers in our work. We should get identical numbers for all the methods for our answer, because they're the same answer no matter what. But that is a little bit of a review of Chapter 3 and the 3 main methods that we had for solving a quadratic equation.